All right, I'm going to go over number 2 from the worksheet. All right, so number 2 is talking about action potentials. So let's talk about, first of all, how this action potential works. Right? So we have the cell is starting out at a slightly negative membrane potential, right? And we know that with an action potential, what happens is the membrane potential rises, it becomes more positive. That's called depolarization. Right? So we have this rising up, and then eventually it repolarizes and goes back down again. Now, what channels are responsible for this initial rise in the membrane potential? Hopefully you said sodium channels, right? We have voltage-gated sodium channels, right, that are over here, this finger, right? Now, when a sodium channel opens, what way is sodium going to flow? We know that sodium is kept at a higher concentration outside of the cell, and so that means that the sodium is going to flow into the cell. Now, when sodium flows into the cell, what is that going to do to the membrane potential? That's a positively charged ion that's rushing in. That's going to make the inside of the cell slightly more positive, and that's going to make the membrane potential rise. All right? Now, eventually that sodium channel snaps shut, and that helps to repolarize the membrane, but it is not enough, right? We also have these potassium channels. And so as soon as an action potential is initiated, these potassium channels open up. Now, when a potassium channel opens, what way is the potassium going to flow? We know that potassium is kept at a higher concentration inside of the cell, which means that once opened, the potassium channel is going to allow potassium to leave the cell. If you have positively charged ions rushing out of the cell, that means that the inside is going to become more negative. And what does that do? That helps to drop the membrane potential back down to resting again. We have this drug, dofetilide, and this drug blocks voltage-gated potassium channels. Right? So you don't have this anymore. So what's going to happen? Will you still have the initial action potential? Yes, you will, right? Because the sodium channels are still functioning just fine. And so sodium's going to rush in, at least the first time it gets a signal, sodium's going to rush in. That's going to cause the inside of the cell to become more positive, right? So this part is going to stay the same. Now, normally potassium channels would open, and that would allow potassium to rush out of the cell. So if potassium is not rushing out of the cell, what is that going to do to the inside of the cell? It's going to stay positive, right? It's never going to go back down, or if it does, it's going to take a very long time. All right, so you're going to have an extended peak, and it's going to take longer for that membrane potential to get back down to resting.